All right, so let's go ahead and jump in with some practice problems for all the different ways that we can undo and rewrite these equations to, again, make them simpler, easier, more accessible to solve. So here's our first practice problem. We have the quantity of x plus 4, quantity squared minus 1 set equal to 48. Now we're going to make a list over to the right side of our problem of each of the steps that we're taking so we can keep track of whether we're undoing or rewriting. So the very first step for this problem would obviously be to get rid of the negative 1 on the outside. So we're going to add 1 to both sides. So by doing that, we are actually undoing it. We are subtracting a constant. So this would be an undo step. Undo, subtract the constant. And again, it's the constant that we care about, the constant that's on the same side as that x value. We don't worry about the constant 48 because that's what's going to be on the opposite side, obviously. So now we have x plus 4, quantity squared, set equal to 49. Our next step is going to be to get rid of that power of 2. We get rid of a power of 2 by square rooting. So we're going to square root both sides of the equation. And of course, we're going to put that plus or minus symbol, as we always do. This again is an undo step. Square root both sides. We're then going to simplify. So we now have x plus 4 set equal to plus or minus 7 because the square root of 49 is 7. It's actually a simplifiable, it's a perfect square root, so we can simplify it to make it into a number. Otherwise, we would just keep it as like the square root of something if we couldn't simplify it further. All right, our next step is again going to be to subtract 4 to both sides, isolating that variable even further. Make sure that you don't put it directly underneath that plus or minus 7. It is going to be two different answers. So we have x equals negative 4 plus or minus 7. And that was again an undo step. Subtracting a constant again. And there's the bell. I'm doing this during my prep period, and so that's the end of the school day. Cool. Now we do need to actually go ahead and rewrite our final answer as the two different numbers that they are. So do make sure that you separate this to be x equals negative 4 plus 7, which is going to equal positive 3, and x is equal to negative 4 minus 7, which is going to equal negative 11. You do need to have both of those final answers written. If you don't have both of those and you just keep it in this form, you will not get full credit. You need to simplify all the way to get the final answer. And you could even think about this as a rewrite step if you really wanted to. You're rewriting using the plus or minus symbol. So we had an undo step, an undo step, an undo step, and then a rewrite step for our final answer. Now you might think that writing all this out is a little bit superfluous, but just know that you are going to have to do this later on as well, so you might as well get the hang of it, okay? All right, practice problem number 2 is going to be 2 divided by x plus 3/10 is equal to 13/10. All right, so what's the first thing you think we should do for this problem? We could start by busting those fractions, right? Multiplying by a common value. Now that would be considered to be a rewrite step. We're going to rewrite to bust the denominators. So we're going to ask ourselves, okay, what is the common denominator between 10 and x? Obviously, it's going to be 10 and x times x. So then we're going to do that. So we take that 10x and we multiply it times 2. Maybe I'll even show all the work that I would really do for this problem. So I'm going to do 10x times 2 plus, change colors for the next multiplying, plus 10x times 3 over 10 equal to, for this third one, 10x times 13 all over 10. People seem to have a hard time with busting the denominators and keeping track of everything as we go. So this would be the longer hand way of doing it. Obviously cross-canceling anything that is common. So I'm going to get rid of those 10s and the x in the first fraction. So the x in the first fraction, then 10 and 10 in the other two fractions. And this is going to leave us with 20, because 10 times 2 is 20. We got rid of the x's from the first one. Plus, looks like 3x is equal to 13x. Cool. So that was all part of the rewrite step. What's our next step going to be? Probably to subtract 3x from both sides. This would be an undo step. Subtract the term. Subtract a term from both sides. That's going to yield us a final or semi-final answer of 20 equal to 10x. Then we're going to undo one more time. Divide by the coefficient. Divide by 10 here, divide by 10 here. X equals 2. So in this case, we had a rewrite step, then an undo step, then another undo step. All right, let's do one more. Practice problem number 3. Let's do 1/3 times 2x plus 5. And that quantity, let's see, minus 2 is greater than 13. Yeah, that'll be a good one. Okay. So this might look a little bit daunting at first. There are going to be a lot of steps involved for this, but it'll be great. All right. First things first, you kind of notice on this left-hand side, this is very similar to vertex form of the parabolas that we've been working with for so long. So what do we always get rid of first? Do we get rid of the a value, the inside values, or the k value first? K value. So let's go ahead and let's get rid of that -2. We're going to start by adding 2 on both sides. This would be an undo step. Undo, add the constant to both sides. It's going to leave us with 1/3 times 2x plus 5 is greater than 15. Our next step is to get rid of that a value, or the coefficient on the outside. This guy, the 1/3 over here. We do that by multiplying by the reciprocal. Sorry, excuse me. We could also call this just multiplying by a common value. You know, it's the opposite of 1/3, obviously, but we could also call it that. So we're going to multiply by 3 to both sides. This would again be an undo step. Multiply by the reciprocal of the coefficient. Three divided by 3, obviously going to cancel out on the left side there. which leaves us with 2x plus 5 is greater than 45. Let's see. Change a little bit darker. All right, we're going to subtract 5 to both sides. Now we're just in a regular two-step equation. Again, that is an undo step. Subtract the constant. That gives us 2x is greater than 40. We're going to divide by 2, another undo step. Divide by that coefficient. And now we have x is greater than 20. So what's funny about this one is that it was all undo. Everything was just like undo, 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 get everything by itself. And just keep in mind that this is actually not our final answer. Remember that we always have to plot it on a number line as well. So just make sure that we have that all taken care of. Empty dot, not filled in. And then x is greater than, which means we're heading up the number line. And there we go. So these would all be examples of how we can use these undoing and rewriting steps in order to simplify and solve and make these problems easier to work with.